we can define composition of a function. This is probably the most complex and probably the only complex things in the context of functions that we have. I think if I have a function g from a to b and a function f from b to c, then we can create a function by composing them. We write this as f composed with g. This is a function from a to c, and the way we are going to get this value of the function is we are going to take the element in a, we are going to find where it maps to in b, then we are going to go over to f, then look at that element that was obtained in b, and then see where it goes via c. So for every element x in a, the function f composed with g of x is f of g of x. That means first apply g, then apply f. Let's look at an example. So here, let's say I want to find f of g of a. Then what I'm going to do is I'm going to start with a, see where it maps. In this case it maps to k. Then I'm going to see where k maps in the function f. It maps to the value 2, and therefore f of g of a is 2. What I would like you to do here is to identify each of these three values. And see that they are exactly what I have on the slides. So we can pictorially view this as this kind of a mapping. The function g is taking you from a to b, and then it will take you to some place in b, then you will take function f to go into set c. Function f composed g is basically taking us all the way across by sort of skipping the set b in some sense. Let's look at two functions. So here I have g is a function 3x plus 2, f is a function 2x plus 3, then f composed with g and g composed with f. What are these functions? I will wait here for a few seconds. You can work this out yourself, and after you have worked it out, you can go ahead and see if your answers are correct. So you should pause here if you need more time. Alright, let's review. F composed with g, that means first we apply g, then we apply f. So it's f of g of x. Well, g of x is 3x plus 2. So I can put 3x plus 2 in this formula. That will give me 2 times 3x plus 2 plus 3. So f of g of x is going to be 6x plus 7. G of f is going to be, I will have you check the math, but it will come out to be 6x plus 11. What is it that I want you to do with this slide? I want you to make sure that you understand why these two functions are computed the way they are. I want you to observe that these two values are not the same, and that means f composed with g may not be same as g composed with f. Here are some more problems to work on. So I have function f, g and h, and your job is to compute a few of the functions like f composed with f composed with g, and so on and so forth. I would ask you to pause the presentation here, and when you have done this, you can go to the next slide to see the answers, to see if they are correct. So here is the answers to the first three problems. Again, you can pause here if you want to review the answers for a longer time, and otherwise I will go to the next slide for the other answers. So these are the answers to the next four problems. What I want you to do is see if each of the answer makes sense. If something doesn't make sense, then you should ask this question on Piazza, as well as discuss it with your group in class, or talk with me afterwards. Now, one observation that I want to make over here is function composition is associative. That means the function f composed with h composed with g is same as f composed with h composed with g. So in associative setting, the order of the functions matters. However, how you put parentheses doesn't matter. So I can think of this as function f composed with g composed with h, and the order in which we put parentheses is not important. However, the order in which these functions appear is important, and that means f g h is not same as f h g. Once again, we have reached the check before you go ahead slide. The key things I want you to get from this video is the ability to do function compositions like what we did here. So I want you to make sure you can work out the function composition that we had and are able to compute it as we did on the slides earlier.